Welcome to a new Voltlog. Today we are taking a look at my electronics mail items. I have a bunch of random stuff today, so let's get started. Our first item is a subwoofer pre-amplifier module. There's nothing fancy about this module, it's just an NE5532 dual op-amp. You get a volume adjustment and a filter cutoff frequency adjustment. You can either connect this as a mono or a stereo input with just a mono output. I ordered this over 2 months ago and I think I was brainstorming the Bluetooth speaker I want to build. I was considering the option of adding a third speaker, a woofer, and that would help cover some of the low frequencies with that speaker system. I'm not sure I'm gonna do that, I haven't decided yet, but I am considering the option and I wanted to have one of these preamp filtered modules just in case. This was under $5 with free shipping and a link will be provided in the description below. A while ago I showed the TP5100 lithium battery charging module. That chip was capable of up to 2 amps and 2S charging in a switched mode configuration. Today I have its smaller brother, the TP5000, made by the same company, Top Power AC Corp. This one can only charge a single cell, input voltage up to 9 volts, battery voltage selection between 3.6 and 4.2 volts, and for that you get this tiny, very tiny solder jumper on board. With that jumper connected, the CS pin is tied to V-in and it charges up to 4.2 volts. Disconnect that jumper and it will charge up to 3.6 volts to accommodate for lithium iron phosphate batteries. Charge current is controlled with the value of this shunt resistor. Right now I have 100 milliohm and that gives me 1 amp charging current, but it can go up to 2 amps with a 50 milliohm shunt. You also get a dual color 3mm LED with the module, so you can solder this to get a status indicator. Right now the best source to buy these is AliExpress and you'll find the link in the description below. Our next item is a motor driver module based on the DRV8833 chip from Texas Instruments. As you can see, the chip is quite small, but it's packed with features. You get dual H bridge inside and the bridges can be paralleled for increased current output. Having this dual bridge configuration, you can drive 2 DC motors or a stepper motor. You get some nice protection features like overcurrent protection, which is always helpful when it is integrated inside the chip. And by controlling the 2 inputs per channel, you get forward-backward control over the motor. All of this for just $1.30 with free shipping for this completely assembled and shipped module. This is crazy pricing. Our next item is another motor driver module, but this one is based on the L9110 chip. This chip has 1 H bridge per chip, but there are 2 of them on this module, so you get the same dual H bridge as before to be able to drive stepper motors or 2 DC motors. You get forward and reverse functionality as well as before. You get integrated clamping diodes and each chip can do up to 800 milliamps continuous current rating. You don't get any of the protection features we had on the DRV8833 chip, and this one is $1 with free shipping, just 30 cents cheaper than the DRV8833. So now, after taking a closer look at this, unless I'm missing something, it seems a better deal to get the DRV8833 module. Next, I got one of these toy-like USB soldering irons just to give it a try. This has been shown numerous times by other YouTubers that I watch. I think Andrea Spice also got one of these and showed it a while back. The listing says 5 volts 8 watts USB soldering iron, so that should be about 1.6 amps. But I wouldn't be plugging this into a computer. I would use it with a power bank, for example, if I ever needed to solder something on the go. Let's give it a try with a power bank and a USB power monitor and see how much current is pulling, how high the temperature will go and how fast it will get there. So you get about 1.5 meters of cable, I think, which is plenty enough when you consider the power bank is portable and you can keep it quite close. Okay, so as we can see, it's pulling 1.8 amps, slightly more than 8 watts, and it's already hot, I think. I can see smoke. Yeah, it's already melting solder. Let's check the temperature. Wow, really fast. So it's up to 370 degrees in like, I don't know, 10-15 seconds. It was really fast. I didn't even get a chance to measure the whole thing because it was really fast. But you see, the temperature regulation is quite poor, I think. It has now dropped to 250 degrees. Okay, so I figured out how this thing works. It doesn't have any temperature regulation, it's just based on a timer. So you get this capacitive touch switch right here on the handle, and once you touch this, the red LED comes on, and it will work for about 20 to 25 seconds, and the tip will, during this time, the tip will reach the maximum temperature of around 500 degrees Celsius. After 25 seconds, if you do not touch that switch, it will turn itself off, and the red LED will turn off as well, so the temperature will start decreasing like we see now. But there is no temperature regulation inside this thing. It's just a heater element, probably something like a 555 timer that is triggered from that switch. Switches a transistor that connects the heating element to the USB line and keeps it that way for about 20 to 25 seconds. So yeah, I think it might be useful someday. I will certainly keep this in my toolkit. It might prove useful someday. It's certainly very compact and easy to take with you when traveling, but you need to be very careful when soldering anything sensitive to temperature, because as we saw on the thermocouple measurement, you get up to 500 degrees Celsius on the tip of this soldering iron. Next item is a desktop cooling fan. Summer is coming here and I'll soon have to work at 30 degrees Celsius, maybe more. So one of these small desktop cooling fans is going to help me while working on the bench. I got this one from Banggood. It was just $3.30 when I got it because of a special offer. I see now it's like $6. It's a Daegu brand, or Daegu, I'm not sure how to pronounce it. It's model number DF001, but there are also other similar models that you can get on the website. Let's plug it into a power bank and see how much current it pulls. Doesn't have anything written on the back on the current it will pull, but I'm guessing less than half an amp. Let's see if I'm right. Let's turn it on. Yeah, so it's pulling about 400 milliamps. So this should be pretty safe to plug into a computer USB port, but I'm wondering if it does induce any noise from this DC motor spinning onto the USB 5-volt rail. But anyway, it does provide quite a cool breeze. Too bad you don't get any speed adjustment, but like I said, for $3.30 I can't complain. I think it will be useful this summer. Next, I have some plastic filters. This was an item several viewers suggested I should get for improving the contrast on the 7-segment displays. Like for the dummy load, which is barely visible in my videos because of the bright lights I'm using here in the lab. So I got two different types. First, there is this plastic one. This was fairly inexpensive, just $1.30 with free shipping. I think it's intended to be used in photography. It's 95 by 85 millimeter in size, about 3 millimeter thick, so not a perfect square, but it's kind of universal, so let's put it to a test. Here is the dummy load, and here's how it looks by itself. And now let's place the filter. As you can see, it drastically improves the contrast and makes the display much more visible. Yeah, this is definitely worth getting one of these. Quite an improvement. This one, like I said, it's about 3 millimeters thick, so do consider that when buying it. You can also get thinner plastic films like these ones. I think I have a set of 12 pieces in here. It was around $8, and they are 30 by 30 centimeters. So it looks like there are 8 pieces in this kit I got, not 12 like I was thinking. I first saw these on the DevPom channel. I think he got them for the same purpose of improving the contrast on 7-segment displays. As you can see, these are much thinner, and it might be easier to use these on your custom enclosure or whatever, but let's check if they really improve the contrast on the display. So dummy load without anything added and dummy load with a filter. Yes, they work, but I think not as well as the plastic thicker filter. Let's try a comparison. So this is with the thin film, and this is with this one. I think this acrylic piece does provide a slightly better contrast, yes, because it masks the background much better than this thinner film. But even the thin film, it's really an improvement, and you can clearly see the display. I think if let's try another color. Let's try this dark blue. Yeah, this one blocks it completely. Let's try the yellow. No, so I think the red filter works best. Yeah, so I'm going to stick with the red filter. I know cutting these to size will be easier with just the scissors than cutting this acrylic piece. So even though it's not as a good improvement as with the solid acrylic one, I think I will still use these thinner ones just because they're easier to cut. As usual, links for these will be in the description below. Next up, I got myself one of these SMD tape sample books. You usually find these complete with parts with resistors, capacitors, inductors, whatever, and you find them in different sizes. But I wanted to get just the book so I can fill it with my own parts, because the last thing I want is some crap quality parts from China, maybe even defective parts. Imagine you are testing your new prototype, or you are repairing something important and you use crappy capacitors or resistors from one of these kits, and you are wondering why your circuit is acting weird. So I will fill this with my own good quality parts. I was already using something similar. I have this business card binder to store my resistors, so I basically built my own resistor book years ago, but this is not ideal, so I wanted to get one of these proper books. If it turns out okay, I will probably be ordering another one just to remake this resistor book. The cost was around $6 with free shipping, and I got mine a bit dented here from shipping, but the seller did offer me like 40% refund, which is acceptable in this case. Next item should be an adjustable current source module. It's not visible through the packaging, but it looks like it could be. So let me get it open and out of this package. So I was right, it's the adjustable current source module. It works with 12 or 24 volts input, and it can output from 4 up to 20 milliamps in 0.1 milliamp increments. So let's connect this to my bench power supply and the multimeter on the milliamp range and test it. But before we do that, just look at the horrible, just disgusting residue that's left on the back of this PCB. Not even sure what this is, but it definitely looks familiar with the isopropyl alcohol white streaks when you clean flux with IPA. It definitely leaves a similar residue if you don't use clean alcohol each time. So I think they might have attempted to clean the flux, but the solution they used was not very clean, and so you get this disgusting white residue. But I can easily clean this off with a flux cleaner. So I got the module powered with 12 volt DC from my bench power supply, and the multimeter is connected on the output measuring the current. So it's right now it's showing exactly 16.8 as shown on the 7-segment display. Let's go all the way up to the maximum. Yeah, it reaches 20 milliamps, and once again the 7-segment display is bang on. Let's check the minimum. By the way, I believe this is like a 5 or 10 turn pot. Yeah, and the minimum is around 4 milliamps as advertised. I'm getting, yeah, 3.7 milliamps, 3.8. And yeah, you can get a pretty fine adjustment. Yeah, I think you can get the 0.1 milliamp adjustment like they were advertising, maybe even better, but you don't get any display for that. I mean, if you want to get better than 0.1 milliamps, you're going to have to use an external multimeter for calibrating that value. So this could be quite a useful module in various scenarios. I think especially in automation systems where you have current-based feedback loops, you can use this to test or calibrate those loops, but also for simpler tasks like testing LEDs. I was curious though how much voltage drop it can handle. Can it do the full supply voltage? And we can easily test that with some LEDs in series. And in fact, I have connected 4 LEDs in series on this breadboard. They are connected to the output of the module, and with the multimeter I'm measuring the entire voltage drop over the 4 LED string. And as you can see, it can drive them with no problem. The voltage drop is 11.72 volts. You divide that by 4 and you get the voltage drop on each of these LEDs, which is something less than 4 volts. So this is excellent for testing LEDs in series, and I'm pretty sure it can go up to 24 volts, its full rated voltage. I'm quite happy I got one of these, and it will be really useful for testing circuits like this. As usual, there will be a link in the description for getting one of these. So I got most of that white residue off, and now I'm pretty happy with how the module looks. My next item is an ESP W-Room O2 module. It's based on the ESP8266EX. So the EX variant is a newer version of the ESP8266, and from what I'm reading, fully compatible, except that it got a few hardware improvements. I didn't dig far enough to find any reliable info, so I'm not sure if you get anything extra out of the new chip or just some improvements on the existing peripherals. Anyway, it seemed interesting enough to get one of these. The cost is $5 with free shipping from AliExpress, and you get the FTDI chip on board for easy programming. So quite similar to any other ESP8266 development boards out there, except this one is made by a different company, has a different layout and FCC approval. These are becoming like the different Arduino flavors. You can get them in so many shapes and sizes these days. And while we're here on the ESP grounds, let me also show you this item. It's a Breakout PCB for the ESP32. So last year I got an ESP32 module, but it was just the bare module, and I later ordered one of these Breakout boards, which arrived even later. I think the first one I ordered did not even arrive, so this is the second one. So now I'm finally able to solder my ESP32 module and get to use it. However, these days you can buy development modules for the ESP32 complete with serial to USB converter chip, and those are definitely a better choice. Next up, two different types of adhesive tapes, especially useful in electronics. This is a Kapton tape roll. It's 30 millimeters wide and it's useful for a variety of things. I was using this thinner roll for years. I think this is 10 or 15 millimeters, but sometimes I need the tape to be a bit wider for better coverage. Most of you probably know Kapton tape, but for those who don't, Kapton tape is a polyamide film that remains stable across a wide range of temperatures. So imagine you can use this tape to hold something that gets very hot, or to protect something from the heat of the hot air gun while working on that board, and it will survive just fine. This other roll is an aluminum adhesive tape. It's 40 millimeters wide, and it's also very useful in electronics. You can use it to electrically shield things, like taping the inside of the enclosures to create a shield, because it's conductive, and you can also use it to protect something from the heat by creating a thermal shield, same as I explained with the Kapton tape. So these two types of tapes should be in everyone's toolkit. They will be very useful someday, and you can get them in a variety of sizes, so choose what's best for you. My next item is a set of two pieces U-shaped aluminum heat sinks. These are pretty hard to find, but you see them used a lot in industrial professional cooling systems. Like in the professional dummy loads or power supplies, I've seen many teardowns where they were using this U-shaped heatsink. This shape is very useful because I think it's very ergonomic to be used inside the enclosures. It doesn't take that much space inside, and also because you can easily blow air with a fan on the end. You blow air through the tube and you get excellent cooling for your power devices. These are 40 by 40 by 150 millimeters long, but you can find them in other sizes as well, so I placed a couple of links in the description. I wanted to have these around the lab, and I'm sure they will be very useful if I decide to build another dummy load or power supply project. Finding nice small compact enclosures for small projects is not so easy. In the Bluetooth receiver project I had a nice small enclosure I got from DigiKey a while back, but ordering from DigiKey is not so easy for me here in Romania, and it's certainly not worth it for a few dollars. So I turned to the usual sources, Banggood, AliExpress and eBay, but I couldn't find any small enclosures. I did find these, which is I think are the smallest I could find, and I ordered a bunch of different models, but it seems none are what I'm looking for. I mean, this is about the size I'm looking for in a small project, but they have these holes for passing wires, and they don't have any screws holding the two sides together. So I guess I'll have to keep searching. This one is slightly better, no holes, so that's good, but it's kind of big and doesn't have any screws holding the two sides together. These two might be useful for a project where you need some vent holes, but once again you get an extra hole right here and it doesn't have any screws to hold the two sides together. And this black one, too big for a small project. Once again, just plastic clips, no mounting holes for keeping this together. And while we're here, let me also show you the last items in today's videos, because they are kind of related to enclosure and assemblies. I got some hardware stuff. Here I have some M3 nuts. I got 50 pieces black and 50 pieces in silver. These are your regular nuts, nothing fancy. Next I got some M3 by 4 millimeter screws. There are 50 pieces in this bag. Should be handy when you are space constrained and you don't have a lot of travel on your thread. This is a bag of M3 brass inserts. So you could use these to create some threaded mounting posts by inserting these into the plastic of your enclosure. And I also got a couple of M2 and M3 taps for drilling threaded holes into aluminium heat sinks. And finally I got a set of polishing brushes for the Dremel tool. As usual, links for all of these will be in the description below if you'd like to check them out. And if you enjoyed this video, don't forget to hit the like button, and I will see you next time.